Hey, I'm Julia. I'm a first year at the University of Waterloo, and I'm so excited to say that after 4 months of planning and trying to understand how motors work, I finally built one myself, a motor that can be used in hyperloops. Here are my motors. Here's the first one. It's kind of heavy. And here's my second one. I built two because I actually came up with the idea to design a new kind of linear induction motor, one that's circular like this, and where instead of being fully linear like that, the coils are made in a circular pattern. And I wanted to see how this would work in comparison to a conventional linear motor, where this is intended to eliminate end effects, which are the main cause of low efficiency in limb. So to build both these motors, I winded all the coils here and here all by hand. And so I look like a Smurf with blue hands covered in copper oxide all over my hands like a Smurf for 2 days. So that was very fun. But for this one, I used a different winding than my circular idea. And this one uses a concentrating winding pattern, which means that the winding is just wound around a single pole. So it's concentrated, while in my circular pattern, I used a pattern called distributive winding so that the coils are distributed on at least 2 different poles. And so here for the concentrated winding, I used 80 turns. And so this was meant to increase the magnetic field as strong as possible to get a high enough levitation force. And in the end, I didn't really get a visible levitation. And for the speed, the propulsion, I got only 5 millimeters per second, which is really slow, but it's still progress and I'm still super happy about it. And initially, I tried to do distributive winding for this one, but there wasn't enough wire, so I just stuck with the concentrated instead. And then with my other circular design, this is what distributive winding looks like on the side here. It uses at least 2 poles, and so it kind of switches between down and up, down and up. And this one used about 20 to 21 turns for each coil. Now, to describe a bit more about how they work, I used, for the primary, the first component of a linear induction motor, I used the primary as this steel plate. It's really thin. It's only about 3/8 inches, but it's really thin, and it has a bunch of holes, which was really helpful to have for putting in the poles. And so the backing was steel, and then I just used a bunch of wood to help stabilize it. Usually you wouldn't have wood, but it was just easier. So that's what I used. And then the primary its main job is to create the first magnetic field from the alternating current that's going to be passing through each one of these coils. And so when an alternating current is passing through these coils, it'll create a magnetic field going here like that. And then when I have the secondary part of the motor traveling here, it will interact, or sitting here, the magnetic field from the primary will interact with the secondary, create some currents here, and then it will induce an opposing magnetic field to counteract the one that's already produced here, and that will allow the secondary to levitate and propel forward. And so for the secondary, I just used a can. It was really easy to use, and I had to make it light considering that the coils were really small and didn't have as much winding as a linear induction motor should have. So this is the secondary, and its main purpose is to create the secondary magnetic field and the secondary currents, which again oppose the primary, as I said before. But it's also really important because this is what allows for motion. Without this, you would not have motion at all. And so this is super important for that. And then compared or contrasting from the other motor here, the only thing different about this one is the primary. So cookie thing. I did not have anything circular that was steel, so I ended up using this cookie sheet, which is aluminum, which is okay, but it would be better to have a magnetic substance or more magnetic substance for here. And so the 2 common materials that would be used for a primary is steel, like I used in this one, or iron. So those were my limbs, and overall they weren't super successful at all, but they were really helpful in helping me learn how these things work, and going forward I want to improve on them. And the first thing I want to try next is making a double-sided linear induction motor. And so what that's going to look like is it's sort of like this, except the double-sided linear induction motor is going to have 2 of these and 1 of these in the middle, which would create more stability, and it would also generate more power too, because you have 2 sets of coils, which is really cool sounding. And so I want to try to make a double-sided linear induction motor because these are the motors that are actually proposed to use in hyperloops and more ultra-fast high-speed trains. And we want to use those instead of just single-sided ones because, as I said before, they can produce more magnetic fields because there's more coils and there's more presence to make those magnetic fields. So that's the main thing. It can produce more magnetic fields, which is able to make it produce more thrust. And so more thrust, and then it also is way more stable than just this single one. Like, it's not very efficient to have just one side here with just the train traveling here. It is okay. That's how the maglev train in China is similarly working right now. But if we want to go even faster, it's important to have more stability, more efficiency, and overall a better working machine that's going to last us longer. So that's my first step, is to make a double-sided linear induction motor. And then the next steps, I want to look for first of all, a new way or a better way to wind coils, because this was exhausting and I don't really want to have to spend 2 days winding coils again. My poor fingers. But so that's the second thing. Double-sided linear induction motor, better way to make or to wind coils. And then thirdly, I want to look more into improving the power input to my linear induction motors. At this time, I used a simple capacitor and that was okay, but it was really, really small and it wasn't enough at all for my model. And so it did the bare minimum it possibly could. I also burned my fingers way too much with using that by holding it and being too close to it and all that. So I need to find a more efficient way to deliver power to both of my motors so that they can run to their potential. Another thing was that my measuring equipment for collecting or measuring the speed of my motors was very, very high tech. I used a ruler and a phone timer, and that was really, really, really inaccurate considering how tiny the distance of the secondary actually moved across my motor, so it wasn't very efficient. And so considering all these things, majority of them are due to lack of resources and equipment. So one thing I'm going to do moving forward is working more with the Waterloop team at University of Waterloo to better understand how these linear induction motors work so I can improve on them and improve existing motors that they have as well, and so I can get better equipment to measure these motors. Another thing I want to do is more research, and my research now I want to be focusing on how we can better maintain the high efficiency as we get to higher speeds. So throughout this time I focused on how we can maximize high efficiency and how we can get to it in the first place. So going forward, I want to focus on how we can keep this high efficiency that we work so hard to get over huge amounts of speed, like 700 to 1,000 kilometers per hour. So that's the first research thing. The second one is how can we maintain a huge public demand for these kinds of high-speed transit systems even decades after, like not decades, but even after months after and years after they are first implemented and first constructed and first presented to society. How can we maintain that excitement so people will continue to use it? And then the third research thing was to better understand how we can improve the funding towards public transportation systems, because there really isn't much we can do long term if we don't have a steady funding for public transportation system. And so far, we have pretty good funding for many other things that happen regularly in cities and in provinces here in Canada, like road maintenance. That's a pretty good one that has a lot of consistent funding towards it. But public transportation doesn't so much. And that's one of the main reasons why its innovation has stagnated so much, especially here in Canada. We need to get a more steady funding. And so I want to understand what it takes to get to that and what we can do to get a longer commitment from both the public and the government.